Hi, in today's video, we'll have a look at a central concept in statistics, which is known as correlation. So very often in research, we're interested in how two variables will covary. And that's because it allows us to answer a lot of questions. So here I've just listed a couple of questions that historians have investigated using statistical tools. So the first one is, are higher levels of protestantism associated with higher growth rates? And so you might see that this refers to Weber's theory around the Protestant ethic. And different researchers have looked into that using statistical methods. The second question is, are higher levels of unemployment benefits associated with higher unemployment rates? And that would be a question that would have a very high relevance in terms of policymaking. And the final example of a question that could be of interest to a historian is the adoption of the printing press associated with high growth rates? So how can we answer those questions? Well, the first step might be to look at a scatter plot. And a scatter plot is a plot where you have the two variables on the axis, so one on the x-axis and the other one on the y-axis, and allows you to examine visually whether two variables are correlated. So for example, here, I'm looking at the percentage of people who are literate within a county versus the average household size within that Prussian county. And we're looking at census data from Prussia in the 1870s. Right? So if you look at this scatter plot, what do you notice? Well, one thing that you might notice is that there seems to be a downward trend between the percentage of literate people in a county and the average household size. Okay, so that means that the more literate the county, the lower the average household size in that county. Right, that seems to be the trend that we observe. Right. Another reason why scatterplot is really helpful is that it also allows you to see other patterns in the data, okay, not just the trend. So for example, here, one clear pattern is that it seems like there's this sort of funnel shape that we can see, okay? So there seems to be very few observations and the variation is quite low in terms of average household size when the literacy rate is relatively small, like for example, around 45% in the county. But we see like that in counties where the literacy rate tends to be really high, like above 95, there's a much wider variation, right? And that's something that a scatterplot allows you to do. So scatterplot is not just useful to determine whether there's a trend or the relationship between two variables, but it also allows you to find all kinds of patterns that might be relevant when you decide to examine that relationship in more detail with more advanced statistical tools, right? So that's the first scatterplot. Let's look at another one. So with this scatterplot, so once again, we have the literacy rate in a county on the x-axis, but now on the y-axis, we have the percentage of the county's population in urban areas. Okay, so just a measure of the urban rate. So here, what do we see in that scatterplot? Well, it seems like there's some data here that so basically a lot of counties with very high literacy rates, but a relatively low urban rate, but still with quite a lot of variation, but at least we see that there's a concentration of data around here. Seems to be a very large concentration of data around there. So where the urban rate is very high and the literacy rate is very, very high. Okay. But then if I wanted to see a pattern between the two variables, I would probably say that there seems to be a positive relationship between the two. Okay. Now, exactly how we would draw that line in this particular case would actually be quite difficult. Okay. And the main reason is because of those observations here. So, for example, if we have a lot of counties that have 100% literacy rates and that are entirely urban areas, then that dot could actually represent a lot of superposed dots, okay? And if that were the case, then obviously when we draw a line of best fit, we would need to take into account all of those dots, not just one, okay? So the line of best fit would also have to take into account how many dots are superposed here. Okay, so whenever you see that there might be a lot of observations that have exactly the same values for two variables, then the scatter plot can be a little bit misleading when looking at trends. So just bear in mind, one thing that you could do to avoid this problem is to add a little bit of noise. And that's sometimes a technique that statisticians use to increase basically the visibility of certain patterns. So here, let's say we had a lot of observations here. Well, we could basically randomly jitter them in one direction. So for example, some of them would become basically you just move them by a little bit. And so that would become more of a cloud of points. And then it would be easier to see that there are a lot of observations around here. Okay. But in general, it seems that with this scatter plot, we have more of a upward sloping trend. Now, what would you say about this scatter plot? So here, it's the percentage of the population in the county that has been labeled as insane versus the average household size. Well, the first thing you notice is that most of the observations seems to be bunched at relatively low levels of insanity rates. And then you have a few counties where the insanity rates seem to be a lot higher. But in terms of trend, it seems that the line of best fit would be something like this, so a horizontal line. So that would mean that there is no correlation between those two variables. Okay, and instinctively, it kind of makes sense. You wouldn't necessarily assume that those two variables would be related in any way. And the data seems to confirm this. Now, the final thing to keep in mind is that the relationship between two variables can be nonlinear. And a scatter plot can be an excellent way of realizing this. So here, I'm plotting the age of convicts from Paisley Prison from 1841 to 1888 on the x-axis. And on the y-axis, I'm putting their weight. And here we can clearly see that the pattern in the data seems to go like this, okay? So at first it's increasing and then it reaches a plateau, which is obviously what we'd expect given that we're looking at age and weight. So we know that when you're, let's say, below 20 in age, you grow up and you put on some weight. And then after 20, your height is not going to change, and so your weight is much more likely to remain stable. Okay, so in many actual questions that you will tackle in your research, the relationship might not be as obvious, but a scatter plot can be a good tool to see if your analysis might require nonlinearity. So that's it for today's video. And in the next video, we'll have a look at how we can measure correlation using mathematical tools.